Assalamualaikum warahmatullahi wabarakatuh. My name is Sarah Binti Azman. We from Group 3 want to present about our project, which is application of ordinary differential equation. My group decided to choose application of first order differential equation, which is Newton's law of cooling and warming. Before we start, I'm going to introduce first the member of the Group 3. The first one is Shin Wei, numeric 279569. The second is me, Sarah Binti Azman, 280611. The third one is Nur Farzana, 2794411. The last one is Amirul Aswad, 264822.
Newton's empirical law of cooling states that the rate at which a body cools is proportional to the difference between the temperature of the body and that of the temperature of the surrounding medium, the so-called ambient temperature. Let Tt be the temperature of a body and let Ta denote the constant temperature of the surrounding medium. The rate at which the body cools is denoted by dTt over dt is proportional to Tt minus Ta. So we have dt dt equal K multiply Tt minus Ta.
The objective of our project is to understand more about the application of first order differential equation in real life. The second one is try to use concept of first order differential to solve the problem. The third one is able to write a detailed solution using appropriate mathematical language, and the last one is able to apply concept of first order differential in cooling warm law.
Methodology. First method is first order ordinary equation, that is separable differential equation. A special type of differential equation where the variable involved can be separated to find the solution of the equation. Separable differential equation can be written in the form of mxy dx plus nxy dy equal to 0, where x and y are the variable and are explicitly separate from each other. After separating the variable, the solution of the differential equation can be determined easily by integrating both sides of the equation. The separable differential equation msy dx plus nsy dy equal to 0 is written as ny dy equal to mx dx after the separation of variables. In this application of first order differential equation, we use method of separable to get the mathematical formulation of Newton's empirical law of cooling. This method also helps us to get an idea and solve the problem in the application.
For the application example, we want to count how long will it take for the chicken to cool off to a room temperature at 70 Fahrenheit. When a chicken is removed from an oven, its temperature is measured at 300 Fahrenheit. 3 minutes later, its temperature is 200 Fahrenheit. So from this information, we want to count how long will it take for the chicken to cool off to room temperature at 70 Fahrenheit.
Before we start solving the problem, we need to know how to get the general solution that used in the calculation. From the previous slide, we have seen in the introduction that mathematical formulation of Newton's empirical law of cooling of an object is given by the linear first order differential equation is d capital T dt equal to A divided by T minus Tm. From that, we need to use the concept of separable, which is it can be written as the product of function involving only capital T while the other one involving only T. The general solution can be found by integrating both sides of as follow. Integration d capital T divide T minus Tm equal to integration A dt. After we simplify and last we got the general solution is function of t equal to Tm and equal to Tm plus C2 exponent AT where C2 is constant.
For the solution, we use the equation Tt is equal to Ta plus C2 exponential to the power of Kt, where we know that C2 is the constant. We know from the information given that T is equal to 300 for when the time is 0. So we substitute it in the equation. So we got T0 is equal to 300, where we substitute the T is equal to 0, then we get the constant, which is 230. We also know that after 3 minutes the temperature is 200 Fahrenheit, so we substitute T is equal to 3 in the equation to get the K value, which is we got negative 0.19018. Then from this information that we got, we substitute in the equation. So we observe that there is no finite solution since the limit t approaching to infinity, tt is equal to 70.
In conclusion, there are many types of applications of ordinary differential equation to a real-world problem, especially in the engineering field. For example, population growth, radioactive decay, and series succeed. So that's all for our presentation. Thank you so much.